we're going to start off in 1.1 with order of operations. And I know you've all seen order of operations before because I actually just an hour ago taught it to my Algebra 1 class, right? So you should have also seen it at that point. All right, so very quickly, order of operations is basically like the fact that we have a precedence for, what we do first and so on. The first thing we do in order of operations is take care of the grouping symbols. The grouping symbols can be parentheses, they can be square brackets, curly brackets, it could be a square root, it could be a fraction bar, okay? Yes.
Order of operations and right?
Yes. And then you evaluate the powers. So after that, you do the powers, all the exponents. Then multiply and divide from left to right. Add and subtract from left to right. So if you do use PEMDAS, right, it's actually M and D all in one step, A and S all in one step. Okay? All right, so let's take a look at this one. Actually, I'm going to give you, so here we have an expression. We have M equals 12, Q equals negative a half. I'm going to give you about 30 seconds to do A and B and then stop. We're not going to change anything to a fraction. I'm sorry, we're not going to change anything to a decimal. Go. M, which is 12, minus 3 minus negative a half squared. So this is 12 minus 3 plus a half is 7 over 2 squared. Okay, now that square belongs to the 7 and the 2. So this is going to be 12 minus 49 over 4. Now I need to have a common denominator. So if this is over 1, I multiply by 4. I get 48 over 4 minus 49 over 4, negative 1 over 4. And all this, we're going to do super quickly, no calculator, and we're not changing back and forth to decimal and so on, right? Because if it's something that you can't, like if it's like 0.625 and you have to square it, we need to be able to work with these as fractions. They're much more efficient that way. Okay, let's do this next one. So we have M, which is 12, plus 2 times negative a half, plus 4. And so order of operations says we have to do the multiplication first. So this is 12. 2 times negative a half is minus 1, plus 4. So altogether, this is 15. Now, notice one thing here. At each step, I have equal to, equal to, equal to, because this thing that I wrote is equal to what was there before, right? When I wrote 15, it wasn't because I felt like writing the number 15 right now. It's because that equals to the thing above, right? Okay, so we don't need the calculators right now, so go ahead and put them away. Okay, so, this one we have a fraction. You need to keep that fraction bar intact. So the first thing I do is equal and this. So J squared, negative 1 squared. Now, J is negative 1. Whenever you have a negative number, put it in parentheses, because negative 1 parentheses squared and negative 1 without a parenthesis squared are very different things. One gives you a positive, one gives you a negative, right? Okay, minus 3, h is 4 squared times k, 0.5. Over j is minus 1, parentheses cubed, plus 2. Yep.
How would you get a negative when you do -1?
If it's -1 squared, then this is negative 1 squared is 1 minus 1. But if you have -1 squared, then it's -1 times -1. The square in this case belongs to the negative and the 1. The square in this case only belongs to the 1. So they're different things. This is +1. Okay? So these two are very different things. Parentheses definitely will matter here. Okay, so now here we're going to have +1 minus 3 times 16 times 0.5 over -1 plus 2. So this is 1 minus, keep the fraction bar, all this together, right? 16 times 0.5 is 8, times 3 is 24, over 1, so this is -23. Okay. Okay. Now, suppose, right, you had the same situation, but suppose k was 0.3 instead. Now, for the same problem, right, j squared minus 3h squared k, now we have a different situation. Now we have -1 squared minus 3h squared times k 0.3, okay, over -1 cubed plus 2. So let's see how this works. So here I have -1 minus 3 times 16 times 1/3, times 0.3, right? Okay, I don't want to multiply the 0.3 to this because then it's like a bit messy. Instead, can I write 0.3 as a fraction?
Yeah, 1/3.
So 0.3 is actually 3/10.
Wait, isn't it +1?
Oh, it is. It's +1. Okay. Over -1 plus 2. So now this will be 1 minus, let's see what we have here. Here, the 16 and the 10 can reduce by 2. So I get 8 and 5. So then this will be 3 times 8, 24, times 3, 72, over 5. Okay? And then over 1. So then 1 is 5 over 5 minus 72 over 5 all over 1. And that 1 underneath doesn't matter. So this is -67 over 5. Now that looks more like a quiz question than the one we did before, right? And again, we're just going to do it elegantly without a calculator, without freaking out, okay? All right. Having kept that as a decimal, not recognizing that you can write 0.3 as 3 over 10 will make it so much more messy and difficult and time consuming. And then you won't have time to finish the rest of the quiz, right? Okay. So here we go. This is the formula for how to convert from Celsius to Fahrenheit. So what is the Fahrenheit equivalent of 40 degrees Celsius? So this is our C. Okay. Now, so basically if C is 40, what is F? Okay. Okay, so here we go. F is 9 over 5 times 40. Yep. So it says, what is the Fahrenheit equivalent of 40 degrees Celsius? That's the Celsius temperature. And in the formula, that's the Celsius temperature. Okay? Yeah. So, okay, yes. Well, let's see. Let's see. So here, we're going to reduce the 5 and the 40. So 72 plus 32, 104 degrees, right? So this is 104 Fahrenheit. Okay? Okay, guys, we are like, okay, we either separate yourselves or let's not chat. Okay, okay. So here we go. So that was section 1, kind of a review of algebra. Let's go to section 2. Okay. In section 2, we're going to talk about classifying real numbers. And the way in which we do that is the following. So all the numbers that you've been working with your whole lives are real numbers. Okay? We can take those real numbers and we can separate them into 2 main categories. And they are rational numbers and irrational numbers, right? So a rational number is a number that can be expressed as a ratio of integers. So like A over B, right? So for example, like 3 over 5 is a rational number. 7 over 2, right, is a rational number. Negative 5 over 3. Negative 2 over 1. 17 over 1. All of these are rational numbers because we can write them as fractions. Now, you see these can have whatever denominator, right? Now, the one specific case when the denominators are 1, those are integers. So out of all these, if we take a smaller subset, when the denominators are 1, those are the integers. Okay? So these are when the denominator is 1. And they could be positive or negative, right? So it could be, 0, 1, 2, 3, ... Or on the other side, negative 1. No. Negative 2, negative 3, ... like this. Oh, hang on, we're getting there. Okay? Integers are positive or negative numbers or 0. The denominators are 1. So we took the whole class of real numbers, stripped it down to just denominator of 1. Now we're going to take that, strip it down further, eliminate the negatives. That's when you get the whole numbers, right? So the whole numbers are just 0 or above. So 0, 1, 2, 3, and so on. Okay? Okay, can somebody start counting for me? Start counting. Right. When I say start counting, you all start at 1. Nobody starts at like 17. Nobody starts at negative 2. And nobody really starts at 0 either, right? So those counting numbers are the natural numbers because it's the natural way that we count, right? So 1, 2, 3, ... So basically, the way in which I've meant for this to be is we take all the real numbers. From that, take just the ones that have a denominator of 1. From that, take just the ones that are 0 and above. From that, take just the ones that are 1 and above. All right? So that's the progression. Now, an irrational number, when I tell you this person's an irrational person, what does that tell you?
Not like they're not real.
Like they don't make sense. Like what they do does not make sense. There is no rhyme or reason to them, right? So irrational numbers cannot be represented by a ratio of integers. And here, I don't know what my copy and paste happened here, but these are decimals that don't repeat and have no pattern. So they don't repeat and they have no pattern. Okay? So for example, pi, right? It's just a, like you have a poster with it. It's just a random series of numbers, right? It never ends. There's no pattern and there's no repetition. So that's an irrational number. Okay? E is another one of those numbers. And then like root 2, it's 1.141, and then like it never ends. Root 3, okay, all of these are irrational numbers. So now, if I have something like this, is this rational or irrational? Rational. If I have something like this, what do you think? Also rational because there is a pattern, right? There is a repetition. What about if I have something like this? Okay, so this one ends. It ends, so it's rational. If it never ended, then it would be irrational. Okay? Cool. Now, mostly when I am labeling these, I use the whole words because the numbers don't make sense. I'm sorry, they have like symbols, but I can never remember these symbols, right? These letters. So you're welcome to use them. I just put them here if you want like a shorthand version, or we're just gonna write them. Okay, so let's classify. Negative 185. Let's write all of the sets that it belongs to. First of all, it's real. So we say real. Is it a rational number or an irrational number? Rational. That's the first thing you should ask yourself. If it's rational, it's possible to keep going. Otherwise, if it was irrational, it would end. Okay, is it an integer?
Yeah.
Yes, it's an integer. What else? That's it. That's it. Okay? Okay, what about root 49? It's real. Rational. Yeah. It's a integer. It's a whole number. And it's a natural number. I mean, and like if you wanted to use the letters, like for the first one, it would be R, Q, Z. It's up to you. What about the next one?
It's real,
Uh-huh.
but it's irrational.
But it's irrational, and that's where it ends. And even though it's irrational, because the square root does not come out to a perfect square, like it'll never stop. Yeah, yeah. Okay, and what about negative 7/8?
It's real.
Is it real?
Yeah.
Is it rational? Yeah. Okay. What else is it? Is it an integer? No. Because for it to be an integer, what should the denominator be? Yeah. 1. Okay, so that's it. All right? Okay, so now we're going to talk about some homework related stuff. Okay.